Okay, let us get ourselves started again, and we're going to go banging on through structural modeling in a very systematic and ordered way so that we can get out in class and give you what you need to kind of keep on going. So I'm going to really focus on trying to build a basic structure just with using the structural modeling tools and kind of get you kind of the essentials that I think you'll need to keep going through all this relative to your building.
Some were anxious actually about structural modeling.
Well, let's see how it works. So what we are going to do, you're going to give me some help on your side in terms of, just understanding your building and how that's all working. Let me go back over to, I'm just going to, let me go back to that structural model. Going to close some things up. I've been messing around all sorts of things over the break, kind of helping individuals out. And I'll come back in and open that structural model again. Cancel. There we go. I'll leave it alone for right now. I know there's an issue with the grids right now. Okay, so what I do is I have some copied grids in here. What I'm going to do is almost just kind of make it clear to myself about like which are my grids versus the copied grids. I'm actually going to go and temporarily just say that for those that linked file, just unload it right now. And the reason is I just don't want to see it. I want to kind of work just strictly with my grids for a little bit. Okay. And I'll go over to level 1. Okay. Oops. Hang on. Go back over here. What's going on? Did I mess around and actually mess up my grids? I might have done that.
You didn't have grids. You unloaded them.
Oh, because I didn't copy monitor them in.
Mm-hmm.
That makes perfect sense, doesn't it? Okay, let me reload those and copy the grids back in. Okay, I will grab those grids. Oh, this is like an ugly looking scale. What scale do you want to work at? You want to work at like, it's a site lit plan, that's why. 8 scale's looking pretty good. What I will do is in that same sort of copy monitoring scheme, I'll copy in these grids. Again, choosing the copy tool and copy, 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 copy. Okay, finishing up when I'm done. So now, with any luck, I should be able to unload that linked file. Okay. Thank you. It appears to have 2 brains. It really does. Very good. Okay, so we got these grids. We're ready to get going. We are going to start doing some structural modeling. Tell me about the structural system in your building. I believe it's a steel frame building. Excellent. Do you have any sort of standard sizes of the steel frame numbers? Like, what are the columns typically? Have you spotted that on any of the drawings? Anybody? Any sort of like columns? We could just going to put some standard ones in there, but probably on some of the structural drawings, you'll actually find maybe in a structural framing elevation. We'll typically find something that'll give us some information. Where are the structural drawings? We'll say part of this is really just digging through and figuring these things out. So I got all sorts of structural details. There's some steel details, structural plans and elevations. That's probably a pretty good place to start. What do we got now? That looks like a lot of stair details and things like that. Let's see what else I can see in here. Let's do that. No. You guys go to work too in terms of trying to figure this out, because you'll need to figure this out. So let's see if we can someone come up with the size of some of the columns in this building, because it's an important thing. Actually, if no one knows this, how are you guys doing your structural modeling? I'm kind of curious.
There is a structural column schedule.
Well, thank you for sharing that. That's what I was asking about. Yeah, don't be shy. I'm up here stumbling around, wasting your guys' time. So you know the size of the structural columns, right? So beautiful. So go ahead and share that with me, and then we'll kind of get it going for you guys. Okay. So what's a good size structural column to use?
We'll go
Okay.
And you have structural column schedule.
Okay, which stage is that? Oh, there it is, right down there. Thank you. Okay, perfect. So let's see what we got going on down here. Yeah. So what we got here, we got all sorts of things in there. I got 14 by 109s that are going up the whole floor. We got some smaller steel tubes. So 14 by 90 and 14 by 109 seem like there's some very common ones. It looks like we even have a little information there. They're going from sort of the foundation level all the way up to, it looks like they're going all the way up to the roof level, which is a little bit unusual, but you know, there's different ways of fabricating. We can go ahead and deal with that. Okay, so let's go forward. We're going to get in some 14 by 109s and 14 by 90s. I'm actually just going to build it as a single level, but you can go ahead and model yours a little bit different. But let's go ahead and kind of talk about how you do this. So the idea is we want to go through and do some structural modeling. For this, I will usually start out with the columns because I think that's the easiest thing, kind of like I start out with the walls. And once I choose that I want to go for the columns, I go to the Structure tab. I'll choose column. We have different sizes here. Okay, so what were those sizes again? Because I never remember from one moment to the next. Excellent, thank you. Okay, so if I don't have the size I need and I want to load in that size, what I can do is, like I do with most things, it's just a family, load in, and I'll say, okay, let's go find some columns. They live in the structural column section. They're steel, and these are broken into different categories, different sections of the steel manual. So if I want to get those wide flange columns, I can open that. And you'll see within there, there's really the whole steel manuals in here. All the different profiles are necessary, are kind of all in here. So you could load them all in, but it really would just kind of weigh down your project. There'd be more data. It would kind of slow things down. So I'll just grab the ones I want, like these 14 by 109s and the 14 by 90s. Pull those in. And you'll see what's going to happen is over here, they're going to show up over in the list of choices. So we're ready to go. Okay. Let's go ahead and I'll work with some of those 14 by 109s. Now, when you want to go placing columns, a couple big choices. One is the whole issue is, are they vertical or are they slanting? Okay. Another big choice is, as you place them, are you placing them relative from the second floor looking down, or are you placing them from the first floor looking up? And again, it's sort of a choice, depending on whether you think like an architect or you think like a civil engineer, okay, you'll approach it differently. As an architect, I will tend to be on level 1 and say I want to give them a height. Okay. If you're in structures classes, you may say you want to go to level 2 and look down instead. Okay. Let me do this.
This is why you're not saying that.
We'll find the beams going to be a very similar issue in just a second here. Okay, so let me do this. You'll notice that because I copy monitored these levels in, I don't really have all my floor plan views available to me. So let me show you how you add those back in so you can make them. So what I can do is go to the View tab and say I need some more floor plan views. And it'll give me a list of the different floor plan levels that it doesn't have a floor plan for right now. So I'm going to add those back in. Okay, that's looking a little better. Let me also add in the ceiling plans, because the ceiling plans cut at 4 feet looking up. That's going to be very useful in just a second for your problem. So we're going to say, great, also under the plan views, let's go to the reflected ceiling plan and put those in there. And again, the issue here is floor plans are at 4 feet or 4'6", never remember, cut looking down. Okay, ceiling plans looking up. The problem we always get in trouble with one of the classics is that if you're looking at a floor plan, you tend not to see the beams because they're above your head. Okay, so ceiling plans are often better. But we'll do the columns first. Okay, so here I am. I'm hanging around on level 1. I want to go through and put some columns in here. So I'll go to Structure, Columns. I'm going to put them in by height. I'm going to put them in by this. I'm going to go from like level 1 up to level 1.5 or 2. I think some of yours go all the way up to the roof. Well, you can put them in that way if you want. I changed my mind, right? Yeah, I say I'm not going to do something that I do it all the time. It's a bad habit. Okay, we will go through and I'm going to do it the other way, just because I think it'll work out better in the long run. Okay, I can go through and now place these, and I can do that by zooming on in. And as I hover over a grid intersection, it's kind of interesting. It's not even showing me that. Let's see if I can put one in there and make it happen. I'm used to them sort of showing up kind of in a ghosty way as I'm starting to place them. I can just place them on the intersections. That kind of works out okay. I'm not sure why it's not showing up as I'm doing it. That one's kind of, we'll take that out in a minute. What happens with all these things is I can put them in. If I hit the space bar, it tries to rotate them. But not to worry. If you're going ahead and placing them in there and they turn out to be rotated wrong, you could always just choose the rotate tool and kind of pivot at 90 degrees that way. So you can place things, and if you place them right at the grid intersections, they'll tend to be pretty well behaved. If the grids move, the columns will move, okay, which is actually sort of what you want to have happen for your model. Now, as you place them, of course, you're going through and creating 3D objects. So if I get that 3D view, oops, that's project 2's 3D view, which I don't believe is the one we're in right now. Do I have a 3D view in this one? It looks like I have not. Yeah, there it is.
Too many windows.
There's something. See what's going on here, because this is that. Yeah, I'm going to close that one there. Here I am. We're going to go back to. I don't have 3D view in this one yet. I'll make the little house, and there we go. So there I have some of these columns, and as I'm going through and placing these columns, let me try tiling these so you can actually sort of see them at the same time. Now that's a lot of windows we don't want to see. I'm going to do something called closing all the windows that are not necessary right now. That's now, since they're all hidden, let me do this. Bring one up. Oh, come on, I'll make it big. I will say now I can close all the hidden windows. That'll close everything except this window. And now I can go back and open that 3D window and do the tiling. That's because I still have that other project open. There we go. So in this floor plan view over here, we have those. Over here, we have them. And we can actually start kind of working away. Okay, I got those big fat columns in there. I can go through and keep on placing them individually, but I tend not to do it that way. What I actually like to do is use the grid lines to my advantage. So what I'll tend to do is actually go through and not do it this way, but say that I want to go through and put columns in. Again, the size is fine, the height is fine, but I'll put them at grid intersections. That's just sort of a very quick way of getting a bunch of columns in at your grid intersections. And to do that, what you can do is come over to your grid lines here, and you can sort of choose some grid lines on control, clicking to get multiple grid lines, and I'll do them in the other direction here. And when I say finish, it'll create a whole little field of them, okay, which is pretty useful. Okay, so that's at least for that section of the building. I'm not going to model the whole building right now, just out of the interest of time. Just going to get some basic columns in there. So columns people tend to get pretty easily. It's really this whole notion of just putting them in there, choosing the right type. Okay? If you have a location where you actually don't need one of the columns, you just backspace and take it out. The fact that you put them in all the grid locations, there's really nothing special, it's just a way of getting them in there. Okay? So it's really created these 8 independent columns, and we're ready to go. So columns people tend to get. Yes?
When you put the columns and the intersections of the grids, can you just write the names of the grid lines, like E or something like that? Or we can pick?
You have to pick it graphically. There's no easy way we can report later the columns and the grid locations. But yeah, it's not like you can sort of type it in and go right in there. At least not in the standard product. There is the whole idea of extending Revit with functionality, and you might want to sort of get involved in doing something like that, where you could write a little tool that would let you put those things in, and it would generate a column at that coordinate. But it's not part of the standard functionality. Although we should check, there might be something like that online, because people are writing a lot of little extensions for it. So good idea. Okay. The next thing we tend to do after we start putting some columns in, let me just kind of show you, columns tend to work pretty straightforward. Once you put a column in there, you can go ahead and change its type. If it turns out it's much skinnier, you can change it to that. It's really just an element. There's nothing kind of special about it, although it does have structural properties that ultimately kind of feed into analysis programs. So it does have some computational ability behind it. But they're really just elements, the same way as most of the different relevant elements work. The other option you sort of need to know about, that's really not a lot of difference, is you can make a slanted column. Your building doesn't have any, so you don't have to worry about that. If you did want to create a slanted column, you would just choose that. And the easiest thing to do is actually do it with 3D snapping. I'll do it, for example, I'll make a column from here to here, and it'll go through and put it at some angle. Okay, but it's hard to sort of sometimes indicate this points in 3D space, so I often sort of find other things and snap to them. Okay, it's sometimes a little bit easier to do that. Okay, but we'll leave it at that. We got some vertical columns. I think that'll work for what you need. Next up, we'll go ahead and create some beams. Okay, and how about beams relative to your beams? Are there any sort of standard beam sizes? And again, from you have that column schedule, load those all in, so you have all those available on the beams. Is there a beam schedule somewhere in this, or on the framing plans? Can you sort of see a couple standard sizes?
You've done the beams, right?
S101. Let's take a look at the mezzanine plan. So we're hanging around here in the mezzanine plan, and where can I see the designations? Are they somewhere written? Where? I'm looking at sort of a framing plan, but I don't see any size outs to steel. Down? That's the reinforced. Oh, there we got some. Got some 18 by 40s. I got some 14 by 22s. Okay, you have some sizes to work with. And from that, super, we'll go ahead and try and frame things up along that. I'm going to just choose the 14 by 22s as a starting point. So I'll come back over to Revit, and I'll choose the beam tool. So we have some standard sizes again here, 12 by 26. If you want to get some other ones, we'll load out to the families. They exist in sort of a funny place. They don't call them beams. They call them structural framing. So what I have to do is open the structural framing folder, and you'll find steel or wood or precast, or you'll find glulam beams, all sorts of things. But most of yours, I believe, are steel. And you'll find the W sections in there. Again, the whole catalog's in here, but only sort of choose the pieces you need. And you can choose more later as you go, but I'll just load in the W14 by 22s now. That's fine. Okay, so now it's going to show up in the list over here too. So we are now ready to start placing some beams, and here's where it gets kind of tricky in terms of the whole thing. Beams are a little bit odd in that they're above your head. Okay, so they tend to be relatively easy to place in 3D. In 2D, you have to kind of think about it for just a little bit. So sometimes when you're placing beams, they just sort of disappear. They're lost to you. So let me show you. For example, over here in the 3D view, if I go through and turn on 3D snapping, and I say I want to place them at level 1.5, although by 3D snapping, I won't really need to do that. It'll sort of figure out based on the connection point what it needs to be. I can click the end here, I can click the end over there, and it'll put them in. If I want to go through and do that in the floor plan view, though, notice this. Let's come on down in here. You'll see you don't see the beams in the floor plan view. And the reason is, for level 1 standpoint, as you look down from 4 feet on level 1, they're above our head. You just can't tell right now. Okay. If I go to level 1.5, you may or may not be able to see them. I see the columns kind of hang around in there. I don't even see the beams there right now. Let me try another view, the ceiling plan view, we'll see if we see them there. The ceiling, again, I'm not seeing that, so let's talk about why that is. Okay, all elements in Revit have different properties that allow you to show them or not show them at different times, and often when we're working on architectural drawings, we don't want to see all the structural elements. Okay, you do want to see the structural elements. So let's talk about how you make them visible. Structural elements are really just a category of, and in fact, these beams, they're in a category called structural framing. So there's some different things we want to check. One thing we want to check is to see, is structural framing visible right now? Because you can turn off entire categories of things. You can turn off the furniture, you can turn off the exterior walls or the windows, just hide things temporarily. They'll still be there in the 3D model, you just may not see them in our plan view or the specific view. Because we do know they're there, we can see them in that 3D view, so we know they actually do exist. So we're going to do a little hunting around to see if we can figure that out. So here we are, we're in the reflected ceiling plan view. I'm going to turn on something called visibility graphics. And This is actually, if you're used to AutoCAD, it's like layering. It just turns on different layers. Okay? And you can actually see that structural framing happens to be one of the layers that's turned off typically. So in your floor plan views, your ceiling plan views, they typically don't show that. So you just need to turn that on. Okay? And then they will show up. Okay, so those little dark lines right there, those represent the beams. So let's talk about that for a second too. What's that? Okay. As you're placing beams, there's two ways to look at them. There's kind of a simple one-line representation. If you look at most structural framing plans, people put simple one-line fat lines to represent the beams. Okay, super. Civil engineers are used to looking at it that way. You have a choice though. In a coarse view, a view which is showing a relatively small amount of detail, so it'll render very quickly, it's a single line representation. If you actually turn it up to medium or fine, you'll see the actual depth. You'll see the representation of the physical, spatial boundary of everything. So if you're not seeing and you want to see it in more depth, just turn up the level of detail. Okay, let me turn that down again. Let's go back over to just a coarse level of depth. Okay, single line. If I turn it back up here to a higher level of depth, okay, then you get the real spatial sizing. So as an architect doing coordination, I want to see your spatial sizing. You know, if I'm just sort of trying to do a real quick steel takeoff, a single line view is probably appropriate. So get used to that the same information can be rendered different ways depending on what you need. Okay. Another thing we should do with our beams, or we can start thinking about doing with our beams as we place them in the model, is tagging them. Tagging sort of gives you the little notations which sort of say what the sizes are, the way it's going to show up in the finished drawings. Let me show you how that works. So under the Annotate tab, you have lots of choices, including, we could put text in there and type in the beam names. But that's actually, it's not taking advantage of the BIM model. The BIM model is this big database. It's full of all this information that's just waiting to be shared with you. So the database knows what the labels should be on that beam. So tagging actually lets you sort of pull that information out. If I say, for example, tag by category, and then I choose that beam, I could put a leader in there, maybe not put a leader in there so it'll show very close. I can actually tag and have that information shown up. In the same way, I could try tagging the columns. It says there's no column tag right now. Would you like to load one? I'll say, sure. I'd love to get one of those in there. So I'm going to go to either under Annotations, Structural. Let's see if I can find a column tag in here. There's a structural column tag, having them show at 45 degrees. So now I can tag those columns. And I'm starting to have something that's looking like a structural framing plan, very much like the ones in the model. Now, the reason I like tagging and what's so valuable about it is if later on someone decides to change the sizing, notice how the floor plans, these tagged views are all updating automatically. Yes?
Would the tag by all work on this plan?
Yes, it would. So, for example, if I came back over here to Annotate, very good question, and say tag all, and I choose a category, for example, let me get all the structural columns and all the structural framing that I can find on here and apply it. Hang on, let's try that again. Tag all structural columns. Apply. Say OK. Why is it not tagging it? I'll think about that. Tag all. All objects in the current view. That should work.
Try one by one.
Yes, exactly. Sometimes my wishful thinking, it doesn't work out. It's like, okay, I try to save too much time. So it will work. So you can go ahead and do the drawing first, put all the elements in place, and then go ahead and add the tags. And tag all is a very quick way to get them in there and kind of get a really quick structural framing plan. Okay, so we got some beams hanging around in here. They're not looking too bad in terms of what's going on. As you place your beams, there's a couple of things I want to warn you about, though, as a structural modeler. And I'll come over here and use this drawing to illustrate it. As we're placing our beams in there, those beams, as we put them in there, we're right at level 1.5. Okay, And that sounds like it's probably a pretty good choice, but actually that's putting them right at the same as the top of the floor level. Okay? And if you start looking around at the sections through the building, you'll see that actually the floor has like some concrete, has a little bit of steel decking, and then the beams are hanging around, but they're actually hanging around underneath that level. You can't actually have the beams intersecting with the floor and the steel. You want them kind of hanging down below, supporting it. Okay, so we're going to do one small variation on these beams. We got to figure out how thick our floor deck is. Okay, the default one in Revit's 5 inches. They put 3 inches of concrete and 2 inches of steel. Okay, and then relative to that, we're going to lower our beams so they won't be penetrating. They'll actually be underneath the floor. And to do that, it's pretty easy. We can grab these beams. Beams have all sorts of properties over here. Beams have, for example, they do have this notion of offsetting them. If I want to put some sort of sloping beam in there, one way to do it is I can sort of put a dimension in there and they'll raise up. And I'll put it in there, back, and we'll put them back down again. But that's not the way I want to do this, because actually I want these to be perfectly horizontal, kind of be very nice that way. So a very quick way of doing that is this notion right here of a Z offset. That's just to depress them in a Z direction. So if I put an offset in there of like -5 inches, okay, it'll just drop them down. So now they'll be underneath the floor slab and you get a good looking section when you go cutting through it. Okay, little minor point, but it's sort of an important point. A lot of people will first put the beams in just right at the floor level and have to go back and fix that. But that's going to be a little bit closer to the construction. So you can go ahead and keep on putting in beams. Let me kind of put some more in here just to kind of complete the picture. I'll put a beam in here. Here's a trick. If you go through and before you place an object, you fill in the properties dialog with some settings, they'll become the default property for new ones you place from here on forward. So if I'm going to have trouble remembering that, I'll just put the -5 inches in there. Okay. And from here on out, as I go placing these, they'll all be -5 inches down. So again, I'll do here to here. I'll do here to here. I'm doing pretty good. Now, if you prefer, and some people do, if you prefer to work in a floor plan view, that's okay. I just like to do them in 3D. It's just dealer's choice about how you want to do it. If you prefer to look in the floor plan view, go ahead and do this. Work in a ceiling plan view more than anything. Where did I put them? It's on level 1 ceiling. There we go. Okay. And as you're placing them, what you have to be careful of if you're not doing 3D snapping is just watch this parameter right there. That's at what level to put them. Because even if you're looking up at the level 1.5 ceiling, if it's set to level 1, it'll put them down on the floor. So you have to kind of watch that parameter. With that parameter turned on, I can go ahead and just gonna be sketching away, putting them in, and just making my floor plan looking ever so nice. I can also do this. This is kind of a fun one. You can go through and I'll see if I can get this to work with you guys. Structure, beams. There's some shortcuts in here. You can place them on grid lines. So what does that actually look like? If you say place them on grid lines, you can choose a grid line. And when you finish, I'm trying to figure out why that doesn't work for me anymore. That's used to work. It's supposed to put them on the entire grid line for you. But it's just fussing with me and not doing it these days. It used to work. I don't know. Select grid lines to place beam along. That's fine. Say finish. Don't know. That is a mystery to me. That functionality always used to work, and I loved it, but it's not doing what it says. There's no beams created, which makes me it's mysterious. So don't worry about doing it if it's not going to work.
It's still trying to do it.
Hmm?
I think you need to cancel that.
Ah, good idea. So if anyone gets that to work properly, let me know about what I'm doing now because it's wrong, because it used to always work for me. And as always, there's some little nuance you're missing because somehow the interface changed and you just got to figure out how it worked out. So how are you guys doing in terms of some beams and columns? Is that sort of feeling okay? You sort of get a sense of that? Okay.
Actually, I have changed the visibility about visible, I still can't see the.
So you change visibility graphics, and then are we looking at the right view relative to where they are? Because that's the other thing to watch out next. So, for example, you've been placing some beams at a level, and then you don't see them in a ceiling plan view. So part of this is structural framing. Okay. So let's think about like what floor plan are we looking at? Right? Okay, so you have some over there. Okay, and again in this one, let's make sure the structural framing's turned on in that one. Because I certainly see all the columns. Yeah. Again, we can take a look at what's going on in your specific machine. How about if I'll keep on going just for the class and the timing, but then let's stop at the end and then let's take a look at specific. We'll figure out why there's always something. There's about 5 different reasons they might be hiding from you. And it takes a little work sometimes to figure that out. Okay, so as you do this and you're working along, I've just been putting in a single size beam, but again, these are all just parts, so I can go through and change them. If you have some of these, that's fine. I know you guys have some, for example, like some steel tubing. So if, for example, you need to have, some structural framing and it's steel and it's like HSS sections, you can find some sizes for that and bring those in. Just grab whatever you need. I'll grab just a couple sizes in here. And I'll go through and say, for example, that one just wants to be some sort of steel tubing instead. And that's fine. But it's pretty much, it's like building with an erector set or Tinker Toys. You just got to connect all the pieces together. And hopefully you're building the basic frame. And it's kind of starting to tie together. Okay. Let's talk about next, we're sort of marching on down, the whole notion of the beam systems. And let's talk about what they're good for. Because the idea is, we've got these big old spans, they're 20 or 30 feet long, and that's kind of okay. But we're going to put some steel decking on here. The steel decking won't span 20 or 30 feet, so there's usually some intermediate joists, some intermediate beams that are going to start to support it. So in your structure, are there some smaller beams, or are there some like open web joists? How is your floor supported? So for anyone who's done the modeling, because we can dig around, but if you've already done some looking at it, let's see if we can sort of figure out what it is. How are the floors supported between those big beams? Does anyone know? Not there yet. Okay, let's see if we can figure this out. Let's go to some wall sections. Those are all the concrete walls. I can see a lot of reinforcing there. That's looking kind of scary. I'm not going to worry about that just yet. What else do we have in here? Let's go to the structural framing plans. Second floor plan. And go up in here. That is just reinforcing. Is that just a pad? It may be that it's really just all done with beams. 8'3" across and stuff like that, and it's sort of a reinforced slab between. That's okay. That actually sort of works. Let me go ahead. I'm not seeing sort of intermediate joists between there. I'm basically seeing like these 18 by 35s. Actually, let's even talk about that, because that actually is a good example. What's happening over here is you can sort of see that there is a whole series of, there's the big beam. Kind of pop out here a little bit. The 61 or 24 by 55, the 21 by 44, you see those big beams running left to right. Then there's these little smaller beams. They're not exactly on a regular pattern. Here they're actually sort of spaced out, very custom about how they're put in place. Let's kind of talk about that and how we can do something like that relative to what we need too. So I'll go back over to the Revit model, and here's the deal. Often what happens is between the big beams, or in your case, the beams and the concrete wall, but your concrete wall has beams in it too, or columns in it too, you'll have some sort of smaller members that connect across. And if you have smaller members that you want to connect across, you can do that a lot of ways. We can go ahead and just grab individual beams, go back up to level 1.5, or 1, ceiling plan. Okay. and start connecting them. So I could go through and grab a smaller beam and just start putting them at specific locations. Something like that. And that actually works out pretty well. If, however, you have a very regular spacing, and your building doesn't so much, but let's talk about other buildings that do. It's a very common condition to actually have very regularly spaced members at a common, 3 feet or every 4 feet or some very kind of systematic spacing. And let me tell you about a concept that you may not use too much in your building. Actually, we're going to use it up on the roof. It's the notion of something called a beam system. A beam system is just a series of beams that are sort of very repetitively put in there where you choose one size, you choose an area, and it just scatters the beams at a very regular spacing across that area. Okay, so let's show you how that works because it's actually a very useful system. So we'll say there's something called a beam system. When you choose a beam system, it has a couple of properties you need to care about more than anything. One is, what is the element that you're going to put in there? And we can put in those 12 by 26s, that's fine. Or we can put in the little hollow steel tubes, something like that. Just whatever the size is. The other thing you have to kind of care about is the spacing. What is it? Is it every 6 feet? Is it every 5 feet? What is it that you need? So I'm going to put them in there every 4 feet, just to make that a little bit difference. Okay. We also have this whole notion of really what elevation they're at. We're working off of level 1.5. That's fine for here. And I'm also going to depress them at 5 inches. I want them to be that same 5 inches lower that the beams are. So I'll say that. Apply all that, and we are ready to start drawing. Here's how these work. Beam systems are sort of like floors and roofs in that you draw a boundary, and then it fills in geometry within that boundary. So what I do is I'm going to choose a boundary. For my boundary, I'm actually going to pick beams as the boundary. And I can choose some different beams and say, basically, I want you to fill in that space with these intermediate members. Now, one of them, you'll notice, actually has 3 little lines there. Those 3 little lines are all about indicating the direction that these intermediate beams will run. So it starts with the first thing I clicked on. That's usually the direction they'll run in. I'll say OK, and we'll fill them right in there. Now, the cool things about beam systems is you can have and choose the whole system as opposed to an individual one. If you want to change that, you can. If you want to change the type of steel that's in there, you can. Okay. They just sort of work as a nice, cohesive, integral unit, and that's actually really, really useful for you. If you need to go through and change the directionality, you can edit that boundary, and one of the choices is not the boundary, but the beam direction. I can say, make them run left to right instead, and they'll run in that direction. So that really, between the columns, the beams, and the beam systems, you usually get about 90% of what you need. So those are really good starting points to get going with. So those 3. So let's kind of pause there for a second before we go any further and just sort of see how those things are feeling. How's this whole notion of beams, beam systems, and like columns? Is that pretty good? Generally okay? Yes?
I know she showed us LOD, like 400, 450.
Yeah.
They start like putting the joints and the bolting and stuff like that in these models. How do you do that here? Is it like also a family that you apply? Or?
It is. There's actually another product that's not sort of built right into Revit. There's something called Autodesk Structural Detailing that lets us work with Revit, where you can choose a connection. It'll kind of pull the elements out, and you can sort of say, I want a haunch, or I want a welded connection, or I want the bolt patterns. And then when you like that, you say, send it on back, and it'll send back a family that has the haunches or the bolts or all the little connections in there. So again, yeah, notice now, in fact, even if you look real closely at this, you'll see all sorts of things. For example, that beam really doesn't touch that beam right now. It's kind of hanging out there in space. What's happening is, by default, just to make it simple to render graphically, it says as soon as something gets close enough that it would intersect kind of the boundary box of an element, it just stops. It doesn't get in there in terms of making a detailed intersection. So, that's generally okay at this level. What you can do, though, if you really care about getting in closer, is there's this notion of coping things together. So how that works is, if, for example, I choose a beam, you can choose a tool over here. There is coping. And what do? First, we select the element to be coped, and I'm always bad about the order. I think that's the one that we're going to change the shape of. And what to cope it to. Oh, tell you what it is. What I have to do is actually sort of extend it before I cope it. What I have to do is just sort of put a little excess material on the end of it. I'm looking for a start extension. Oh, it's actually right there. Now, why is it grayed out for me right now? I would want that to be there. Uniform, offset. It's just there. I should be able to extend that. I'm going to think about why I can't and not know right offhand, so I'm not going to belabor the detail now because, again, we're going to be running up against time. But, yeah, just know it's out there, and we can sort of get into the detail of it more later. But there is this notion of being able to kind of like bring things together and sort of fix that problem. So we can talk about that later, but definitely yes. I mean, I would love to be able to kind of like bring that together. That's in the coping tool, but I got to think about how they've changed that interface right now because my extensions are right there right now. So no, okay. But let's keep on going. We got these basic kind of elements kind of popping together, looking pretty good. If you want to kind of keep on going, you can. At some point, you'll probably add the floor slab to this. It looks like you just have a big old concrete slab which sits right on top of this. So if you want to go through and put that concrete slab in, kind of an interesting thing is really who owns the concrete slab. Does the structural engineer own the concrete slab or does the architect? Okay, you can decide that on your team about who really is going to own that slab that's sitting on top of all these. Okay, what I'll typically do is go up to level 1.5. I'll go through and put a floor slab in there. Slabs typically are foundation elements we talked about there. I'll just say that's a structural floor. And I can go through and choose. That's the concrete on the metal deck. That's what I would use in most buildings that have that sort of construction. If you don't have that, if you really actually want to make something that is really more like just a 5-inch thick concrete slab, again, what I'll do is edit the type, duplicate it. I'll call it just reinforced concrete. Okay, and do that same sort of thing where it has some properties. It's going to be 5 inches there, or whatever the appropriate thickness is for you. Make it cast in place concrete. Okay, and now we're ready to draw the floor. I think a lot of you sort of stumbled across floor drawing already. It generally is sort of all about drawing a boundary. Okay, let's go ahead and just kind of close that up. For the concrete floor, notice that it actually does, because it's a structural floor, have the notion of rebar and what the cover distance is. So it can actually get into the actual very detailed steel detailing. Okay, but if we go through and look at that, yes. Weird. Okay, as you're working with floors, generally floors work out pretty well. I'm going to show you that floor over there. Those columns are ready to be kind of poking up beyond that. There we go. They're ready to kind of go up there. If you need to cut a hole in your floor, cutting a hole in your floor is amazing, like cutting a hole in your roof. What you do is, you say you have a boundary, you want to edit it, and what you do is just basically draw another boundary within it. Okay, and that'll cut away that hole. So if you have like some sort of a hole for a mezzanine or you have holes for a stairway, you can go ahead and just kind of cut holes right in there, and that'll sort of work. Now, someone actually asked a very good question at the break. I'm talking about that. There's ceilings versus floors, and you might want to sort of put ceilings in your spaces too. Ceilings aren't necessarily the same as floors. Very often you go through and have a space between the ceiling and the floor below, which is the plenum space that'll enclose the steel so you don't see it from the bottom. You can run mechanical equipment and things like that. If you want to put a ceiling in your space, we go to the ceiling plan for level 1 and show you how you do that. I could go through and grab the ceiling tool, and there's different types, either 2x4 or 2x2, just sort of acoustical ceiling tiles, and you can sketch a ceiling or make it go within walls. Let me draw that. I'm going to put a ceiling in here. Okay, ceilings have a property. There's this whole notion of really at what level they should be, and here's what you have to watch out for with ceilings versus floors versus all those. Think about how you want your ceiling to ultimately be related. Is your ceiling always going to be a constant height off the floor? Okay. Or is it going to be at a constant depth relative to the floor above? Okay, and just what you want to define that. The difference is, if you make it a constant height like 8 feet off the floor, no matter how high level 2 gets, okay, it's going to stay at 8 feet. If, on the other hand, you do it so that you say, I'm going to show you. Finish that up. Let me draw a little section through this just so you can sort of see it. So what's going on there? You'll see I have some steel. Actually, I have a ceiling in here too. That's the ceiling over there. Let me turn up the level of detail. It'll make it a little bit easier to see what's going on there. So I have my steel up here. I have my ceiling down here. It's kind of hanging around looking pretty good, but it's always at 8 feet. The difference is if I hang it off the floor, if I go through and move the floor above, the ceiling's going to stay at exactly the same place because it's really defined as being relative to the floor. So no matter where I move that floor, the ceiling stays the same. The difference, just so you know about it, is if instead you say you want to basically say, take it and make it relative to level 1.5, but make it a certain distance relative to 1.5. Okay. Looks like it's about the same, but now what happens is if I move the floor, the ceiling moves with it. So just think about what your relationship in all these parametric models. This is relationships you put in between the different things. And there really is a hierarchy to this. It often starts with, first you get the grids down in the levels, and then you put the floors on the levels, and then you sort of decide where the ceiling is going to be relative to the floor. And there's sort of a way these things are constructed where it's a whole hierarchy of decisions that build on each other. And there's great power in that, because then if you need to make a modification, it kind of comes out just right. Okay, let me pop back out to that 3D model, and we'll just do a couple more things there to kind of get you going. Okay, I've been doing pretty good in terms of making this model and kind of making a single floor. That's kind of okay. If you want to go through and actually kind of have a second floor, what is often a very useful thing to do is copy the first floor elements up to the second floor. In many, many buildings, it's very, very repetitive, and it'll work very nicely for you. So you can do things like just take this whole floor assembly right here. I'm going to grab the floor too. Copy it to the clipboard, and then paste it up to another level. So I could paste it to another level, and I'll paste it up to like level 2 or something like that. And I'll basically get a whole second level relative to it. Now, because my floor levels are a little uneven, I'll need to do a little adjusting to the heights. But it's a really quick way of sort of getting a building that then you can start adjusting and making the specifics to it. But very often you do want things to line up and kind of do that. So that's kind of a quickie way of starting to get your building built. But let me kind of show you another thing that I want to show you just relative to the roof, because that's one that I know you are going to encounter. So let's go ahead and take these columns, and I'm going to extend them up a little bit further. I'll take it up to the tower level right now, just so we have something to work with. Okay. Yikes. Oh, that's because I raised the tower level very, very high. Okay. Maybe we'll fix that. Make you a little more reasonable. Okay. When it comes time to go through and frame that roof, the roof in many ways will be very, very similar to some of the other things we're doing. Although the thing that's a little bit different about the roofs is it tends to actually have sloping elements. They don't lie flat. They actually kind of lie at some level, and you would like to have your framing follow that. So let's just kind of even sort of think about how that would work. So for example, in here, let me go to the roof level, for example. Let me go ahead and just sort of put a roof over an element of this building, and we'll see how we can get the framing to adjust to it. So what I'm going to do is say, basically, let's take a roof. I have to set the roof plane, roof level. I'm going to draw a boundary for it. Now, roofs, as we saw earlier, are very, very similar to drawing floors. The big difference is that they have like some sort of a directionality to them. So I can leave it turned on from all the sides, or not. Let's take a look at that. Okay, so we have this big roof kind of hanging around on top of this. So as I go through and I put in the elements, as I put in the beams, what I really would like to have them do is follow the slope of that roof. Okay, so let me show you what I mean. So I drew a section in there. Let me kind of just extend it up a little bit. There we go. So I got my roof on top there. What I would really like to have happen is I would love to have the beams that I go through in place at the roof level actually follow the slope of the roof. So when you're going to be doing beams, and I think even a lot of light gauge steel on your roof too that you have to get in place, here's how you can approach that in terms of really quickly putting things at a sloping angle, because let's kind of talk about the ways you can. I could go through and, let me go back out to the 3D view. I could come through here and, let me hide that roof for just a little bit. Say that what I want to do is, I'm going to put a beam in here, just like I've been putting in beams so far. And I'm going to draw it on over here. But what I'm going to do is sort of put an elevation change in it. This is the way I used to do it a long time ago. I'd say, great, I want that to be 8 feet taller, say okay, and you kind of put it in there, and it does that little bit of a kind of lift for you, and you're thinking that's pretty good in terms of what you need. But it sometimes takes a lot of work to kind of get that to be just the right amount of like slope relative to the roof. Okay, so that's one way to approach it, and I could put a bunch of those in. I could say, great, this looks fine, and copy it over. Put some more in there, and copy that, and put some more in there, and kind of get a whole series of sloping beams like that. That'll actually work for you. Another way you might do that, just because I think at the roof level you get fairly regular, is you can do an array. I can say, let's array that. Again, I'll put in a number like 6 or 7 of them, 8 of them maybe. Sort of choose a distance, and it'll put a whole bunch in, and it can make a whole series of sloping roof beams that way. Let's talk about slope and how we can really kind of do that a little bit better. The deal is, all these things, as we've been putting in the beams, we've been putting in like all these different elements of the framing, we've always been on a work plane. Okay, and typically that's been a nice horizontal work plane. Level 1 or level 2, it's been a nice horizontal surface. Turns out we can define our own roof plane to follow a slope and place it on that sloping plane, and it will take care of a lot of the heavy work for us by just saying that you want to place them on that sloping plane. So let me show you how you do that, because that's really it's one of my favorite tricks for working with roofs, and I think it's pretty easy to work with or to get you guys going. So here's the deal. Maybe I'll do it in the section view. So here I am. I got my roof over there. I would love to put a whole bunch of beams in here that are hanging to the bottom of that roof, supporting that roof. So here's how you can go ahead and approach it. We need a plane. We need a work plane. So all these floor plans, they've been creating planes for us. That's A-okay. We're going to go through and create a plane, a reference plane. We can draw the plane or we can pick it. Picking is almost always a better choice if you have a piece of geometry that you can hang things to, because then it'll always follow that geometry. So if later on you decide your roof is 612 or 912 or whatever it is, it'll adapt to it. So I'm going to pick a plane. I'm going to pick that plane right there. Okay, now it's pretty uninteresting so far, but it's creating a surface we can work with. I need to give it a name. It's always good to give these things a name. Let me go ahead and say that this is kind of the north roof. Okay, So why am I doing that? That's just going to allow me to now place beams at that slope, okay, very, very quickly. So let's show you how that works. So I got my north roof slope. That's looking good. Let's go up to some sort of a ceiling plan or something like that. Sort of bad about, there I am, at the roof level looking up. I want to put some beams in here. So here's what I want to do. I'm going to go over and choose my beams. Looking good so far. I'm going to say that I'm going to draw them. That's fine. For my placement plane, level 1, 2, roof. Ooh, north roof slope. This looks attractive. Let's see what happens here. If I choose the slope as being the placement plane for the beams, what happens is when I go through and draw them, okay, single line view only because we're at a coarse level of detail, fat line view. Go back to 3D. It's there. It's just kind of hanging in space in a funny space. There it is. So if I turn back on the roof, it'll be there. But if I go back over to that roof plan again, as you're looking at that roof plan that you brought in as a DWG or you brought in as a JPEG or whatever you brought in as, and you're putting your beams in here, super. I got them on that plane. I can start copying and pasting whatever it is I need to do to kind of put them in here. Okay. And they're all going to be placed at that slope, okay, which is then going to save you a lot of time later. And the good thing about that whole slope is if later on someone actually says, you know, that model I gave you, it wasn't quite right. That roof isn't 912, it's really 612 or 512 or some lower level. Okay, it's down. I expected that to rotate down too, but we can fix it easy enough. Try to rotate on that. Okay, beautiful. What's going to happen now is in 3D, okay, all those beams have sort of adjusted themselves too. So allows you a lot of flexibility in the long run. So, you know, we talked about beams, beam systems. Trusses I don't think you're going to need so much, so let's leave that alone for right now. And let me finish up with this whole thing about the merging. But let's stop there for just a second, which is what's going on. Two last things. Okay. In terms of foundations, who started on the foundation of this building yet? Anyone? No one yet. Okay. In terms of foundations, a couple of big foundation systems you may need to know about. Slabs you probably get a handle on. That's kind of like just doing a big floor. That's pretty easy. The other type of foundation that you probably have more common than any other system is something called an isolated foundation. And what that's all about is if you have big old columns that are coming down and they're just bearing on the soil. Okay, here's the deal. All that weight coming down to the building, coming down on that very small area. When it crushes down on the soil tends to fail and give way. Okay, because it's just too many pounds per square inch for the soil to bear. So what we want to do is put a little bit of a concrete pad under there to spread it out. It's like the problem with like stiletto heels. If you've ever had someone step on your toe with a pair of high heel shoes, it's incredibly painful. Where that very same person in a pair of sneakers, they could stomp all over you and you wouldn't care. It really makes a big difference to have all that weight concentrated. So here's what you got to do here. Isolated footings. We could load one in. Let's see what we got out there in foundations. We have all sorts of footings. We have plain old square footings. We have footings that have piles, depending on what your soil conditions are here. We should take a look at what that is. Just all sorts of different conditions of really what these could look like. I'm just going to go for a simple rectangular one now. It has some sizes, and again, if these aren't your sizes, what are you going to do? You're going to duplicate and kind of change the sizes to be what you need. Then I can say, let's go ahead and place them at the columns. I'm going to say, you need a footing. You need a footing. You need a footing. You need a footing. I feel like Oprah. Come on, you. I knew you needed one. Okay, and place those footings in there. What is good about those footings? Those footings will also follow your columns. And they're also going to follow the floor level. So if anything changes, we're going to be in good shape. So go ahead and, if it turns out they're actually a foot below or something like that, no worries. -1 foot. And we can lower our footings. So yeah, footings are actually very, very good in terms of like being able to work with that stuff. Okay, so a little bit about footings and how you do that stuff. Okay, that'll get you going with most of what you need.
I'll cover whatever is left next week.
Okay, let's do the last thing, which is that linking of the files. Okay, who's got a nice set of model files that are linked and you want to pull them together in a single file? You. Okay.
Basically, a grid line linked to the structural and the
Okay, and you would actually like to get them all back into a model. Okay, well, that's it. For doing, is this just so you can see them all together, or do you want to actually merge them together and have them all be one file now?
probably for now, just to see how it all connects.
I like it. Good answer. Good answer. Okay, because yes, once you merge them together, they're all mushed. Okay, so when you go through and you do these and you want to bring them all together, let's see what we got. So, I got my incredibly fantastic structural file here, which we certainly want to keep. Let me save this away. Okay. I probably have some architectural model hanging around in here too if I saved it. Let me go through and say that I want to insert and link another Revit model. Did I save anything? I didn't save anything. I have Noah's midterm project.
We can look at his files.
Let's do that.
Your teammate? Okay.
Let's get teammate. We'll solve it with the real problem it's supposed to make you one up. Okay. Remind me about your second floor beam is not visible. We'll figure that one out. Okay. So we will extract all these again. We'll go back over to Revit and we will open, just depends, like let's say you're doing the architectural one and you want to go ahead and look at the other ones.
It's there. Teammate.
There it is.
It's up.
Oh, there you go. Thank you.
Building structure.
Okay, let's open the architectural. Okay, it's complaining because can't find that it's not no longer in your central location. That's okay. This won't happen to you. Okay, so here's your architectural model. It's looking good. Let's go ahead and bring in and flip it over to 3D so I can take a look. Beautiful. Let's go ahead and bring in your structural model. What I'll do is come over to Insert and I'll say Link. Go to Teammate Structural. And there it is. Let's bring that in. Not center to center. I hate center to center. Origin. Oh, that looks so much better. Okay. That's okay. Actually means you already linked them together, so it wasn't going to reload the link. Because your structural model already linked to the architectural model, it said, I'm not going to relink the architectural model to create that infinite loop. So here they are together. In the architectural model, if I want to save this so that I don't have to relink it again, I just save it. And now the link is stored. So now you're bi-directional. He changes something, you're updated. You change something, he's updated. Okay, so that's actually a really good way to do it. Let me go one other one, see if I can do this. There's those. Now we're in there. So here's another one. It's called binding link. If later on, so much further down the line, when it's finally time to turn this over, if you really do want to get these things together and have them be a single file so you no longer have to worry about having multiple files. Okay, again, don't do it for your process here, only later in life. At the end of the class anyway. You can bind them together. What the bind does is actually, it's going to turn the link Revit model or pull it right into here and it's going to be a whole. So then that's kind of the quickest way. So when we talked about sort of being able to copy and paste, that would also work. But this way it does it with precision, so you get the coordinates and the origins just right. Okay, beautiful. Let us pause there out of respect for our next class. I'm going to save the videos so we can kind of play that back for you guys. We will stick around and answer some more questions. I need to sort of save the video and get out of here out of respect for the next instructor. So give me just a minute to get that process going. And if anyone wants to hang around, I'll definitely be around for the next couple minutes. We can sort of take a look at any sort of specific problems people have.